Okay, so today we are going to talk about light. Is it a wave or is it a particle? Well, to some of you, the conclusion of this video may seem pretty absurd, as it did to me when I first heard of it. But let's not spoil everything to those who don't know this. Let's start, okay? Back to the 17th century, Sir Isaac Newton and Sir Christian Huygens proposed two complete theories of light. But the hitch here was that Newton thought that light was a particle, while Huygens thought light was a wave. So, what is it? In this video, we will observe some phenomena. Okay, I will particularly demonstrate one of those phenomena, but we will see some of those phenomena and derive our conclusions from them. The first one I am going to talk about is the reflection of light. This can be explained by the both particle and the wave theory. As you can see, this particle theory, light coming from a source, whether far or near, it comes as a stream of particles, hits the mirror, and bounces off or reflects from the smooth surface. In the wave theory, light comes as a wave spreading in all directions and hitting and reflecting in the opposite direction, with the back shape going in front to produce a reversed image to the observer. So this phenomenon can be explained in any theories of this, so this doesn't give us any distinction between them. The second one I'm going to talk about is refraction. This is also the same case. It can be explained by both the particle and the wave theory. In the particle theory, Sir Isaac Newton explained that the particle which bends its path coming in a denser medium and accelerates lateral. And as you can see illustrated here, force is pulling particles towards it and opposite force is pulling out it, and it returns to its original direction of velocity. In the wave theory, wave bends when coming in a different medium and bends again coming to its original shape. It's sort of like this, the results are the same, the explanation is different. This Christian Huygens explained very well the medium dependent propagation of waves to explain the refraction. So this doesn't give us any conclusion either. So the next one we are going to talk about can only be explained to the particle theory of light. This is the photoelectric effect. Photoelectric effect is the observation that many metals emit electrons when light shines upon them. And it has been measured that to this electron, by a stream of electrons be directed, the way or the nature of light must be like a particle. It must be small packets of energy. So this basically means that light is a particle. No? Yes. No, it doesn't mean that light is a particle. The next experiment is a blockbuster experiment. I will show you how to do this at home because it is a very fascinating experiment and you can do this at home very easily. There was an experiment by which we can show the wave function of light. This I will explain later. Okay, so for this experiment, you will firstly need a laser pointer, preferably a 5 milliwatt of power, a sharp tool, any sharp tool, you will know why it requires later, a candle, some matches, and a plate of glass. Be careful to handle the glass, it can be dangerous. And this. So how to make it all up? First, light up the candle like this, and then hold the plate of glass above the candle, which will darken it up. Be careful to handle it because the glass may crack if you hold for so much time, and it should not be transparent when you can darken it completely. And that's how basically you do it, but I have already done it on the other side, so I will show you just the demonstration. And this is actually the setup. This needs here, you'll have to scratch it up this side, the darkened side, just scratch it up and carefully draw narrow, straight, and almost as possible parallel slits. So, and okay, so I am using my rooftop as the laboratory. After the settings, you have to draw narrow slits within the darkened part, scratch them just, and sorry I didn't include that in my video tutorial, but anyways, do that. And that plate of glass will be actually the key part of our experiment. Set the laser in a platform like this, balanced to the level of the glass dish. This is the plate of the glass plate. This here you can see I have used a tree tube for the adjustment. You can use anything that adjusts the heights, and light up the laser. And and remember, you have to have a white background there. My interference pattern is a bit higher, I will adjust it later. And a white background, the interference pattern will emerge on the white background when the laser goes from the two slits and hits up there. Okay, so let's see the results. So this is the time for results, and there you see the laser pointer. I have adjusted many things. You have to, it may take 2 or 3 tries to get the thing right. Here is the laser pointer, 5 milliwatt, and I've adjusted the height of those two as I said, and the laser is pointing towards this darkened part where there are 2 slits linking the part, and the laser is going to both slits at once. Okay, here is the laser pointer and this, and let's take a look if you can see the slits. It appears that here you may see that those narrow pathways. Here are the slits. You can see them now. Yes. And this is hitting on that white background where there is interference pattern. I will show you in a moment. Here is the pattern you get. You see the form of stripes, narrow stripes, and the middle one is the brightest. And this is not something you will expect. You will expect 2 narrow stripes like this if the laser is going through 2 slits at once, but there are many stripes, including some between the slits, which we will explain. And this is due to the wave function of light. This is a clear definition. So what the hell is going on? Well, something is definitely going on. Yeah, and you can see this image here where it's illustrated that exactly what is going on. Look, in this illustration, it used a broader light source or some kind of torchlight and passed it through one slit and then passed it through it, but I don't need to do that because I used a direct laser. Okay, so in this case, light is coming as a wave. Okay, this. And when the 2 waves, these 2 slits act like 2 sources of waves. And when 2 waves emerge from these 2 and then collide with each other, in some cases, here, the waves cancel each other. In some cases, they heighten each other. In that way, in some cases they lower each other, some cases higher each other, some cases completely cancel each other. A cancel wave is a wave that does not exist. So that cancel waves are the result for these darkened spots. And those heightened waves are the result of these spots. Okay? So this we call the interference pattern. Pattern of a wave. So, is light really a wave? Oh, okay, so throughout this video, I have shown you many distinct behaviors of light, particle and wave behaviors. And we have seen that light sometimes behaves in a particle type of way and sometimes in a wave type of way, only in wave only. The funny thing is, with the double-slit experiment, that the laser I used was red in color, and the color of lights strictly depend on their wavelength. And the laser itself works because it emits photons in a control where photons are particles and as well as waves. So what is light? As we can see, it is both. Okay, it is both. I repeat, it is both. I know to the people who are familiar with this concept, they will not surprise a bit, but who are not familiar with this object and just seen it, they'll be just crashed down. So this light sometimes behaves in a particle, sometimes behaves like a wave, and sometimes like a particle and a wave in the say at once. So this nature of light is called the wave-particle duality. All particles also have a wave nature, including electrons, photons, as we can see, neutrons, and all. Through the work of many other great scientists, such as Albert Einstein, Louis Broglie, Niels Bohr, Max Planck, and many more. Current scientific theory holds this, that all particles also have a wave nature. And waves are sometimes referred as a mechanical wave and sometimes also a distribution of particles in space.